Hi everyone. Today we will see the question paper, Physics Paper 3, Theory, May-June 2023. First question is, a student measures the diameter of some identical steel balls, shows the arrangement. She uses the arrangement. So here it is marked A, B. So first question is, using the ruler in figure 1.1, determine the distance AB. So we need to find the distance AB. So first we'll see what is the distance in centimeter up to this point B. Up to point B, here it is 5 point. This is 5.5, 6, 7, 8. So from here to this distance, it is 5.8. And we will measure this distance also. This is actually 1.5. 1.5 centimeter. So effectively, this distance will be 5.8 minus 1.5. That will be equal to 4.3 centimeter. Next, use the distance AB to determine the diameter of one steel ball. So total it is 4.3, and there are total of 1, 2, 3, 4, 5, 6, 7, 8. 8 balls are there. So we can divide it by 8. So the total length it is 4.3. That one divided by 8. So we'll be getting the answer 0.54 centimeter. Next, the mass of some steel balls is 54 gram. And the total volume of these balls it is 6.9 centimeter cube. So what is the density? So density is equal to mass by volume. Mass divided by volume. So here the mass is 54 gram divided by volume. It is 6.9 centimeter cube. So when you are dividing, you'll be getting the answer as 7.8 gram per centimeter cube. Next, figure 2.1 shows the speed time graph for a cyclist. In the figure 2.1, the sections ST, TW, WX, XY and YZ indicate the stages of cyclist journey. So here we can see ST is here, TW, WX, XY and this is also there, YZ. State 1 section which shows the cyclist moving with constant speed. So here you can see this is constant speed, that is ST. This is in constant speed. WX also, the cyclist is moving in constant speed. So anyone we can write, we'll be writing here ST. Constant deceleration. So deceleration means this one, YXY. So this represents the deceleration XY. Constant non-zero acceleration. Constant non-zero acceleration here. TW represents acceleration and XY also represents negative acceleration. So any one you can write. TW. Calculate the distance traveled by the cyclist in the section ST. So ST means from this point to so up to here. So we need to find the area under this graph. This is a rectangle, so length into breadth. So here length is 8 and this breadth will be, this is 10, 10.1, that is 11, 12, 13. So 8 into 13. So the distance traveled will be equal to BH you can write, and that is 8 into 13, that will be equal to 104 meter. Figure 2.2 shows the horizontal forces on a cyclist. So we can see here he is moving forward with a force of 220 Newton and there is a frictional force backward that is 160 Newton. So calculate the size of the resultant force on the cyclist. So for finding the resultant force, we can just subtract, that is 220 Newton minus 160 Newton. That will be equal to 60 Newton. State the effect, if any, of the resultant force on the motion of cyclist. So if you are increasing this force, there will be an increase in speed. So the speed will increase. It will be more. Next, a student has a battery powered torch. Figure 3.1 shows the torch. Figure 3.1 shows the energy transfer when the torch is switched on. The diagram is incomplete. We need to complete the diagram. Show the energy transfer in the torch by completing the labels. So in a torch, in a battery, the chemical energy is being stored. This chemical energy is converted to light energy. Output we are getting is light. And some power dissipation happens and thermal energy will be released. So what is the thermal energy here? That will be total energy, it was 100 joules minus 70 joules, that will be equal to 30 joules. The weight of the torch is 8.5 Newton. The student lifts the torch a vertical distance of 0.8 meter to the place it on a shelf. So he's placing it on the shelf with a vertical distance of 0.8 meter. The force applied is 8.5 Newton. Calculate the work done on the torch by the student. So work done can be written as force into distance. So force is 8.5 Newton and the distance is 0.8 meter. So total it will be, when you are multiplying, you'll be getting 6.8 joules. The student places the torch on its base on a shelf. The area of the base of the torch is 44 centimeters square. Weight of the torch is 8.5 Newton. Calculate the pressure on the shelf due to the torch. So the equation for pressure is force divided by area. So here the force is 8.5 Newton. That one divided by 44 centimeters square. So when you're dividing, you will be getting the answer as 0.19 Newton per centimeter square. Next, a student has a block of solid metal at room temperature. Describe the arrangement, separation and motion of the particles in the solid metal. So as it is solid, the arrangement will be, it will be having a regular arrangement. It will be fully packed. Regular arrangement will be there. So separation means it will be closer. Will be closer than liquids and gas. And the motion means it will be vibrating. We know the solids are closely packed with a regular arrangement, and inside the molecules will be just vibrating, and the particles will be in a fixed position. The student cools the block of metal in a freezer. State the effect, if any, of cooling on the kinetic energy of the particles. So we need to find the effect of cooling. What will happen to the kinetic energy in the block of metal? So when he is cooling, the moments of the particles will decrease. That means kinetic energy will decrease. State the name of the temperature at which particles have least kinetic energy. At absolute zero, particles will be having least kinetic energy. State the value of temperature at which particles have the least kinetic energy, include the unit. Absolute zero means it is 0 Kelvin, or we can write it as minus 273 degrees Celsius. The metal block emits thermal radiation from its surface. State two features of a surface that is a good emitter of thermal radiation. So black color, it is a good emitter of thermal radiation. And if it is a dull surface, dull black, it is a good emitter of thermal radiation. Next, a observer stands at P and looks into a rock quarry. A small explosion has taken place at X in the quarry. Figure 5.1 shows the situation. The observer first hears the sound from the explosion 1.8 seconds after the explosion occurs. The speed of the sound is 340 meter per second. So calculate the distance xp from the explosion at X to the observer at P. So we need to calculate the distance from this X to P. This distance needs to be calculated. So distance is equal to speed into time. That can be written as speed is given as 340 meter per second into time is 1.8 second. Second will get cancelled. So 340 into 1.8, that is 610 meter. The observer then hears a coital sound from the explosion. So this is how the coital sound waves reach the observer. So again he is hearing some small sound. So that is an echo. It is an echo from rocks. Before the explosion, a warning siren produces a sound. The wavelength of the sound is 0.28 meter. The speed of the sound is 340 meter per second. This is the wavelength. Calculate the frequency. So frequency can be written as wavelength the speed of the sound divided by wavelength. That is 340 divided by wavelength is 0.28 meter. 340 meter per second. So here you will be getting the answer in hertz. That is 1200 hertz. So this is 340 meter per second divided by 0.28 meter. So this meter and meter will get cancelled. 1 by second means it is hertz. Figure 6.1 shows light waves passing from air into a glass block. So we can see the bend here. State the name of the process shown in figure 6.1 as the wavefronts enter the glass block. So here the waves are getting refracted. So the process is refraction. State two changes in the light wave as they pass from air to glass. So there will be change in speed. Change in speed will be there. Change in direction will be there. Changes in wavelength will be there. Figure 6.2 shows a ray of red light traveling through a glass fiber. The glass fiber is made of solid glass. State and explain how the ray of red light travels through the glass fiber. So we can see here the ray is getting reflected internally. So the phenomenon happened here, it is total internal reflection. So inside this total internal reflection is being happened. So why this total internal reflection is happening? So the rays when it is incident on the surface at an angle and the angle of incidence is greater than the critical angle. So when angle of incidence is greater than critical angle, total internal reflection will occur. And when the red light that is traveling from denser medium to less denser medium. Here the red light is traveling from more denser medium to less denser medium. Next, a student uses a permanent magnet to lift some unmagnetized nails. Some of the nails are made of iron and some are made of steel. Figure 7.1 shows the magnet lifting the nails. Each nail lifts the nail below it by induced magnetism. So, what is meant by induced magnetism? So, these are actually not magnets. Steel and iron is a non-magnet. So, a development of magnetic properties inside a non-magnetic material, that is actually induced magnetism. Temporary development of magnetic properties. In a non-magnetic substance, that is induced magnetism, and these nails will be occurring. Here it is note means this will be S, this will be N, this will be S. Like that it will get induced. The student leaves the nails attached to the magnet for several hours, then removes the magnet. State the difference between magnetic property of the iron nails and steel nails. So iron, it is a temporary magnet. It will act like a temporary magnet. And steel will act like permanent magnet. So steel always retains the magnetic properties. Next, a metal wire XY is connected to a voltmeter. The wire is placed between the poles of a permanent magnet. Figure 7.2 shows the arrangement. State the reading of the voltmeter when the wire is stationary between the poles. When the wire is stationary, there will not be any reading. It will be 0 because no EMF is being induced here. Give a reason for the reading on the voltmeter when the wire is moving in the direction. So when the wire is moving, an EMF will be getting induced. So there will be current flow. So the voltmeter will start deflecting. So here an EMF is induced when the wire is moving. That means it is cutting the magnetic field. Next, a student uses the circuit figure in figure 8.1 to measure the resistance of the heater in the circuit. The symbols for the meters in figure 8.1 are incomplete. Complete the symbol for the 2 meters by writing in the circles. So here we can see 2 circles are there. So this will be ammeter because we need to connect the ammeter always in series with the load, or current can be measured in series. And we need to connect the voltmeter always in parallel with the load. That is, voltage can be measured when you are connecting in parallel. Next, the current in the heater is 1.4 amps and the potential difference across the heater is 8 volt. Calculate the resistance. So by Ohm's law, V is equal to I into R and R is equal to V divided by I. So the voltage is 8 volt and current is 1.4 amps. So 8 by 1.4, that is 5.7 ohm. Next, the heater is switched on for 30 seconds. The current in the heater is 1.4 amps and the potential difference it is 8 volt. So calculate the electrical energy transferred by the heater during 30 seconds. So the electrical energy transferred can be written as B into I into T, that is equal to voltage 8 into current is 1.4 amps into time is 30 seconds. So we'll be getting the answer 340 joules. Next, A student has a desktop computer that connects to 240 volt AC mains electrical supply. Figure 9.1 shows the desktop computer. The desktop computer has an on-off switch in one of the wires that connected to main supply. State and explain which wire includes the switch. So turning on and off, we need to connect the switch in the live wire. It needs to be connected in the live wire. And when the switch is in off position, the computer or the desktop will be disconnected from main supply. When switch is off, desktop is disconnected from supply voltage. Disconnected from supply voltage. And there is no current in the computer. Computer will be off condition. The desktop computer uses a transformer to change the voltage to 40 volt AC to 12 volt AC. State and name of this type of transformer. Here the voltage is getting reduced to 40 volt to 12 volt. The voltage is getting reduced. So we are using here a step down transformer. Describe the construction of this transformer. You may include a label diagram. So in a transformer, soft iron core will be there. You can see the laminated core here. Then primary winding will be there. Primary coil, copper coil will be there. Secondary coil will be there. So copper wire will be there as primary and secondary winding. Here this is a step down transformer. So primary number of turns will be more. So number of turns in the primary will be more and more number of turns will be there in primary than secondary. That is NP will be greater than NS. Number of turns in primary will be greater than number of turns in secondary. Next, iodine 131 is a radioactive isotope of the element iodine. Figure 10.1 shows the nuclide notation for the nucleus of iodine 131. So here you can see this. So downside it is actually proton number and this is nucleon number. Determine the number of protons in one nucleus of iodine 131. So number of protons it is, this is the proton number. Downside it is proton number, that is 53. Determine the number of neutrons. Determine the number of neutrons in one nucleus of iodine 131. So number of neutrons will be equal to total. It is 131. Inside nucleus, protons plus neutrons it is 131 and the number of protons is 53. So 131 minus 53 will be getting the answer 78. When a nucleus of iodine 131 decays, it emits a beta particle and a gamma ray. State the nature of beta particle and the gamma ray. So here beta particle means it is an electron and the gamma means it is a electromagnetic wave. A sample contains 1.6 mg of iodine 131. The half-life of iodine 131 is 8 days. Calculate the mass of iodine 131 remaining in the sample after 24 days. So here we need to find total how many half-lives are there. So half-life is 8 days. We need to find after 24 days. So 24 divided by 8, that is, we will be getting the answer as 3. So 3 half-lives. So 1.6 mg is the current state. So after 3 half-lives means by 1 by 2 into 1 by 2 into 1 by 2. 3 half-lives. So that is 1.6 divided by 8. So it is 0.2 mg. Next, figure 11.1 shows the Sun and the 4 innermost planets A, B, C, and D of the solar system. In table 11.1, write the names of innermost planets. So here 1 means that is nearest planet, that is Mercury. Next it is Venus, Earth, and Mars. So here A is Mercury. Next Venus. Third one it is Earth. And the fourth one it is Mars. Describe how the 4 innermost planets of the solar system were formed. So it is formed by the continuous collision. And so much dust and gas particles and that contains different elements nearby the sun. So through continuous rotation around the suns and the continuous collision lead to the formation of planetary core. So there is a protoplanetary disk of dust and gas surrounding the sun. So this helped in the formation of innermost planets. And there is a continuous collision that lead to the formation of planetary core. Thank you all. We'll see in the next video.